let's start with these two questions here. Let me just gauge from you guys. Are we able to answer question 3.1 by ourselves? I want you guys to have a look at it, read it really quickly, and tell me, yeah, ma'am, I got you. Okay, I've got one thumbs up, which I'm liking. Next week, Friday. Oh my goodness, Lieutenant, your school doesn't like you. They don't like you because next week, Friday is holiday. I don't know what they're on about. But next week, Friday is the holiday, dude. Like, you should tell them, I'm not writing paper 2. I'm on holiday. Oh, next week, Monday. Okay. Yeah, I remember there was somebody writing on Monday. There's someone else writing on Friday. Okay. So we're doing these questions specially for you, Lutendo, to make sure that you get that 80% on that paper too, my darling, because we're all rooting for you. Okay, so let's start with 3.1. I've got one thumbs up. I would like everybody to just have a quick read at 3.1. Tell me if you're able to answer it all your own. Give me a thumbs down if you'd like me to walk you through it. I can give a couple of hints. Would we like hints? Or are we happy to go straight in and answer the questions ourselves? Okay, absolutely. I can do hints. All right, so let's read the question together really quickly, and you'll see how easy it is for us to know this. All right, so it says here, show that a triangle ABC. All right, so we know we've got a triangle, right? Okay, I'm just going to let you guys know before we get into this question that this is an analytical question, an analytical geometry question. It says, we want to show that a triangle, oh, sorry guys, I don't know what's happened. I'm sorry, my OneNote just closed. And so I need to figure out exactly what's happened so that I can get back on screen. Just give me a second, guys. Let me see if my computer will make the pots to do the things that can be done. Okay, success. All right. Okay, so we're told that it's a triangle and it has the vertices A, B, C. So they've given us the coordinates of A, B, and C, and they want us to show that this triangle is an isosceles triangle. So first thing I'm going to do is I'm going to draw myself a tiny little triangle. I don't have to name it A, B, C because what I'm actually trying to do is I'm trying to figure out exactly what it is I should know about an isosceles triangle. What should we know about an isosceles triangle, great hens? What should we know? Anybody? You can't see the screen because I forgot to reshare the screen. Thank you. Thank you, Vika. We're doing great, guys. We're doing great. We're doing so wonderful. All right. Okay. Good, Narisha. That's good. Just let me know, guys. Can you see my screen now? Yes? Give me a thumbs up if you can now see my screen. Amazing. That's going to go so great when we have to edit these for YouTube. That's going to be so wonderful. Such a wholesome moment. Okay. All right. So we know, as Narisha points out, that angles are opposite equal sides. That actually means something. It's not just the reason we give for isosceles triangles. It actually means something. What it tells us is that if my angles over here are equal, then they will be opposite equal sides, which means this side over here must be equal to the side over here. Now, because we are working with analytical geometry, we're not going to be able to use the angles. We're not going to be able to use the angles. There comes a time when we do use angles. That's a grade 11 problem. But for now, what we need to find out is whether AB is equal to AC. How are we going to do that using analytical geometry? Who's got an idea? How do we do that? How do we see if two sides are equal? Which formula do we use? Yes, Narisha.
We use the distance formula to find AB's distance and AC's distance.
Excellent. Okay. Beautiful work, Narisha. Just See, again, teacher Narisha could take this class. I see it. I see it. I could just take a back seat for today, and Narisha can teach the rest of the lesson. I like it. Okay, all right. So I want you guys to bear in mind, right, that they've told us that this is triangle ABC. But let's say, for instance, you calculate the length of AB and you find that the length of AB is 7, and you calculate the length of AC and you find that AC is 10. That doesn't mean that this particular question doesn't work. It just means that we've picked the wrong sides. Okay, all it means is that instead of figuring out AC, I should probably look for BC instead. Maybe that one would equal 7. But because we are showing, that means we are proving that it is an isosceles triangle, which means 2 of the sides must be equal to each other. Thumbs up. Am I making sense? It might not be the 2 sides that we've picked, but let's try with those 2 sides and see what we get. Can I give you guys, this is a 4-mark question. Can I give you guys 4 marks? I'm sorry, 4 minutes, not 4 marks. I'll give you guys 4 minutes. All right, cool. Take it away. I'll just give you the marks. Okay. Okay, I'll give you the marks if you work for them. It's unfortunate. Sorry, guys. Sorry, Gift. Sorry, Narisha. I'll give you 4 minutes and 4 marks after 4 minutes if you've worked. I'm quickly going to change my color of my highlighter. Okay, good. I see some people are done with a lot of time to spare, but I like it. Everyone else, you've still got about 2 and a little bit, 2 minutes and a little bit. So we'll give it some time. Hello, Mandisa. All right, guys, that's time. Shall we talk? Okay, I'm going to rely on you guys here please just tell me, did AB and AC work? Excuse me. Did AB and AC work? Give me a thumbs up. Otherwise, I don't want to have to do a whole calculation for something that might not work out the way that I need. Did AB and AC work? Yes. Or do I need to switch to AB and BC? Which one worked? Anybody checked it out? Because if I do A, B, and AC and I don't get the right answer and I have to do a third thing, we're going to waste a little bit of time. Okay, let's start with AB. AB is equal to the square root of, now I'm just going to remind us the distance formula, open brackets x2 minus x1 squared plus the y2 minus y1 all squared. All of that together. All right, so we'll start with AB. I know that for AB, I'm going to get negative 10 plus 2 all squared plus 1 minus 0, which is just 1 all squared. And that will give me the square root of negative 10 plus 8. That's 8. 8 squared is 64 plus 1. So we're looking at the square root of 55. So AB is the square root of 65. Root 65 is AB. Let me try AC. Let's see. AC is equal to the square root of, I'm going to get negative 11 plus 10 all squared plus, over here I'm going to get negative 7 minus 1 all squared, and I can already tell that is 1 plus 64, so that's the square root of 65. And because the two sides are equal, we can therefore say that ABC is isosceles, is isos. Okay. All right. Did we all manage? Yes. Thumbs up. Were we all okay with this? Oh, Mandisa, you should let us know how you did in just a little bit. Okay. But before we get to that, I want us to have a look at this question. Now, I specifically included this question because I want to make sure that we all understand that when your teachers in grade 8 and in grade 9 take you through the properties of quadrilaterals and all that stuff, it's not just for the sake of Euclidean geometry, it's part of analytical geometry as well. And when you get to a point further down the line, trigonometry also involves these kinds of things. So it's important that we understand them. And so I've picked this particular question so that we can have a look at this. Now, I want us to note that in 3.2, there is a lot happening in this write-up. There is so much happening in this write-up. But when I look at my Cartesian plane and I look at my drawing, there's only two things here. And there's no way that everything that's written over here is expressed there. So we now need to read and add in all the other things that they haven't put into the drawing. Okay, that's why ma'am says step number 1 in any of these questions is always to read the information you're given. So I'm going to give everybody 1 minute, read the information, make sure you're understanding it, pop me an emoji when you're ready to go through the question. There is a lot of information there. Okay, there's a lot of information. So read it carefully. Yeah, it's very hot and humid here. All right, thumbs up. Have we managed to read through the information? Should I give you guys some time? Okay, great. No, my computer's fighting me again. Just give me a thumbs up. Can you guys see my screen? Yes. Oh, that makes one of us. So that makes one of us. So let's give it a second because I can't see my own screen right now, and that's not helping. Sure. Okay. I'm gonna try and see if I maybe open and close it again. I know. I don't know. I think the computer on my side is frozen. I think that's what's happened. And so now I'm not able to see anything on my side. Oh no. Oh, there we go. Okay, it's come back. It's come back. All right. Let's not jinx it. Let's not jinx it. Okay. Hello, Abu. Great to see you with us. Okay. Okay. All right. Behave. Okay, cool. Sure. Technology, guys, technology is not my friend. All right. Okay, let's start with the information. Now, you'll see here, no worries. You'll see here, there's a lot of information. We need to take it a step at a time. Okay, it says here, in the diagram, ADCB is a kite. Very important information because we need to know the properties of a kite. Let's start with simple things. We know that the adjacent sides of a kite should be equal. So that side must equal that side. We also know that the diagonals should bisect, not really bisect. They should cross each other at 90 degrees. Not in this case, actually. It doesn't look like. Okay, but we'll go with that for now. Okay, it's supposed to be 90 degrees over there. Okay, we know that this diagonal will equal that one. Okay, and as far as we can get in a kite. All right, let's continue with the rest of it. Okay, it says A is -3 and 5 that they've added, and B is 1 and -4 that they've added for us. They tell us that AD is equal to DC. So we know that this side is equal to that side. We should expect that of a kite. Then it says AB is equal to BC. So we know AB. This side over here is equal to that side. How this helps us in analytical geometry is that we know that the distances are the same or the lengths are the same. Therefore, the distances must be the same. Okay. Then we're told D is a point such that AD is parallel to the x-axis. Okay, so AD parallel to the x-axis, and AD is 5 units. So from there to there is 5 units long. Okay, CD is perpendicular to the x-axis. So CD, this part over here, perpendicular. All right, to the x-axis. And the longer diagonal bisects, there it is, bisects. So they tell us that that over there is equal to that, bisects the shorter diagonal at P. Okay. Yes, let's see if any of that is in there, Abu. Let's see. All right, let's start with 3.2.1. Okay. 3.2.1, 3.2.2, and 3.2.3. Are we all, oh, 0.2.4 is also quite easy. Thumbs up, are we all able to answer these 4 questions? They're all 2-mark questions, so they're not going to be that difficult. Yes? Okay, I'm going to give you guys about 5 minutes. The reason for that is because 0.1, 0.2, 0.3, easy. 0.4 also easy, it just takes a little bit of time. So 5 minutes, let's say maybe 6 minutes to get each of those. Okay. We've got about 3 minutes to go. I hope you guys are doing okay. I'm realizing now I'm not sure how to lay out 3.2.1 so that you get the maximum 2 marks, but we're going to try it out. Okay. In the next 2 minutes, we'll try it out. Okay, I'm going to see if I can find the way that they want you to write it in order to get the marks. This is looking a bit takey at the moment. All right, peeps, are we ready? Can we look at the answers? Okay, awesome. All right. So the first one is kind of obvious, but also it's a bit tricky because even me as the teacher, I'm a little bit worried about how do we express this so that we get the full 2 marks for the question. Okay, so they want us to show that the coordinates of this point C over here is -8 and 0. Now, logically, we can work this out. We know that the distance between A and D is 5 units. Now, if I track this properly, if I track this particular line, because it is parallel to my x-axis, if I track it properly, if I track it this way, I know that everything sitting on this line will have a y value of 5. All of them will have a y value of 5, which means the coordinates for D, or the y coordinate for the point D, is 5. I know that for a fact, because they're all sitting on that same line, right? The next thing I know is that the x values are 5 units apart, but 5 in the negative x direction. Okay, which means that if this is -3 over here, if I move 5 units in the negative direction, my x coordinate for D needs to be -8. Okay, so that's just mathematically or logically, really, not even mathematically, logically, that should make sense to us. So I think that's something worth mentioning. We should let them know. We should say here, AD is equal to 5 units. Let's start there because logically that would make sense. Therefore, D, the coordinates for D would be -8 and 5. Okay, thumbs up. Is everybody okay with what ma'am has just explained here? We cool with that? Right. Okay, Buikanyo, are you a little lost? Do I need to explain something again, my darling? Let me know. I'm so happy to do so. Are you good? Okay. All right. Okay. So now I know that the coordinates for D are -8 and 5. I've also been told that CD is perpendicular to the x-axis. So I know that CD is perpendicular to the x-axis, right? And if they're perpendicular, that means that they will share an x value. That one and that one will share an x value. It's just that for the C value, I've moved 5 down. Therefore, my x value is 0. So if I say that CD is perpendicular to the x-axis, therefore, the coordinates for C must be -8 and 0. Okay, let's write this down. Don't quote me, though. Okay, I've shared the memo with you guys on Teams. So have a look at how the memo looks for it. But logically, if you don't have a memo and you're writing the test for the first time or the exam for the first time, we're not going to be 100% sure how to lay it out. But I can tell you, if a teacher can read it and they understand your mathematical process, they'll probably give you the marks. Okay. All right. Let's look at 3.2.2. It says here, write down the coordinates of P. Now they've told us that the longer diagonal bisects. What does the word bisect mean again? It means it cuts something into two halves, right? And these two halves are exactly equal, which means this side over here is equal to this side over there. What does that make P? Who can tell me? P is the what? The midpoint. Sure. Abu, you don't have a maths problem. You've got a handwriting problem. So maybe we weren't paying attention in grade 1. You know, remember when you all did A, up, around the world and down, around the world and down. We need to go back. Okay, I'm just kidding. I'm just kidding. Yeah, because we need to be able to read what you're saying. Okay, let's calculate for P. P, all right. I know I'm going to use the coordinates that I've just found. I know that P is the midpoint of AC. So remember again, the formula for the midpoint, x1 plus x2 over 2, brackets y1 plus y2 over 2. And remember, the coordinates or the midpoint gives us a new coordinate. It's not like the distance formula, the gradient formula, where we get a singular answer. We get a new set of coordinates here. It's not just a figure. All right. So I'm going to label these. Let's label this one over here, x2, y2, and we'll label a x1, y2. All right, and then we just substitute into the formula. So I'll get -3 plus -8 over 2, semicolon, because that's the x value. And then for the y value, I will get 5 plus 0 over 2. So I should get a fraction, but it's fine. We know fractions. We should be able to deal with fractions. Equals the coordinates of P. -3 minus 8 will give us -11 over 2. And 5 plus 0 will give us 5 over 2. All right. And that's the answer we should get from there. Okay. All right. 3.2.3. Calculate the gradient of line BD. That's easy enough. We know the formula for the gradient. We also learn about the formula of the gradient from the equation of a straight line. So we should know m is equal to y2 minus y1 over x2 minus x1. All right. So I'm just going to write the answer over here. 3.2.3. The gradient is equal to, and then I can label again, make that x1, y1. Make this x2, y2. Okay, the gradient is going to equal -4 minus 5 over 1 minus -8. And it's looking like it should give us -9 over 9, which should be -1. So the gradient of the line BD is -1. All right, and then 3.2.4 says calculate the length. We know that the length is the same as the distance. So we're going to use the distance formula to calculate for this. Distance formula, the distance of AC. Okay, AC is equal to the square root of, and I've already labeled them x1, y1, so I'm going to use those labels again. Okay, so -3 minus -8 will give us +8. All squared plus y2. Oh, I've done it the other way around. So I'll have to do it the other way around here as well. 5 minus 0 all squared. Okay, is equal to, yeah, all of this is equal to AC is equal to the square root of 5 plus 5, 5 squared plus 5 squared. So that should give us the square root of 50. If you've punched this into your calculator should give you the answer 5 root 2. That's the answer you should get. Or you should get something along the lines of 5 comma something or 6 comma something along those lines. No, 8 comma something. I'm lying. I'm definitely lying. No, 7.1, 7.2, something along those lines. All right. I just want to check, is everybody happy here? Yes, thumbs up. Are we able to do 3.2.1.2.3.4? Those are the standard That's why they're all 2 marks. You'll see most of your analytical geometry is easy marks. So we should be able to get all of those. Okay, now 3.2.5. Let me just check because I know this happens very often and it happens normally in matric. So this is not the time for you guys to drop the ball. Thumbs up. How many of you know the formula for the area of a kite? Because it's not given on a formula sheet. I didn't think so. Okay, I didn't think so. So those are the small things that they expect you to know in matric that you somehow just like, they showed you once in grade 8 and then you forgot. It always happens that way. Okay, so let's talk about the formula for the area of a kite. I'm going to draw a tiny little kite just to explain. So if I have a kite here, okay, I know that that's one of the diagonals. That's the other diagonal there. The formula, so we'll call this diagonal 1, and we'll call this one diagonal 2. The formula for the area of a kite is diagonal 1 times diagonal 2 divided by 2. Okay, so please draw this so that you know what the D1 and the D2 means, but this is the formula for the area of a kite. Okay, so now if we look at what we need to do here, okay, we need to find the diagonals. Luckily for us, in the question above, we've just calculated the length of AC. So the only thing, that's diagonal 1. We've got diagonal 1 now. The only thing we're really missing is the length of diagonal 2. Okay, we need the length of diagonal 2 in order to calculate for the area. Can I leave that up to you guys? Yes? Thumbs up. Are we happy to do that? Yes? 3 minutes. Go for it. We're going to calculate the length of DB, and then we're going to calculate for the area of our kite. Oh. Yep, that's it, Narisha. That's it. Sure, Lutendo's already done. Like a rock star. I like it. I like it. Guys, this is how we know we can count on Lutendo's A in the exam on Monday, because she's doing the things. She's doing the things. Oh, Abu says in the... Okay, no, the area of a rhombus is just the area of a square. Okay. So what you needed to do was, oh, I'm lying. You needed to use the base and the perpendicular height. So you would have had to use Pythag to find the perpendicular height. So if that's your rhombus, you use that as your base, and then you just need to find the perpendicular height. Sure, there was Pythag too. Amen. Okay. That's good, Abu. That's good. All right. Okay. Let's look at the distance BD quickly. I know that I should get the distance of DB. It's already named for me. Oh, excellent. Narisha finished just in time. Okay. BD is already labeled. So x2 minus 1 minus 8 will give us 1 plus 9, all squared, plus the square y2 is negative 4 minus 5 all squared. So that is the square root of 10 plus 100 plus 81. So the square root of 181. Did everybody get that, or did I move too fast? Is that the correct answer, guys? Did everybody get square root 181, or did somebody get a different answer? I'm hoping we all got the same answer. Let me just make sure. 1. Oh, yes, I'm definitely lying, guys. So this should be 1 plus 8. It should be 1 plus 8. Sorry, I went straight to 9 and I wrote it down. Sorry, guys. Sorry, guys. Yes. So 1 plus 8 would be 9 squared. Okay, 9 squared plus 9 squared. So the square root of 81 plus 81, which is 9 root 2. Okay. Okay. Sorry about that. So we should have gotten, what is 81 times 2? I don't actually know. 81 times 2 is 162. We should have gotten the square root of 162. The square root of 162, which is the same as 9 root 2, sorry. Which is the same as 9 root 2. All right, let's calculate for the area. We'll just go area is equal to diagonal 1, which is 5 root 2, times diagonal 2, which is 9 root 2. All of this divided by 2. Okay. Therefore, the area is equal to, now here's the nice thing about mathematics. 5 times 9 will give us 45. 45. And then I know that square root 2 times square root 2 is the same as the square root squared. So it will be just a 2, and that 2 will cancel out with that one. And we'll have 45. And in this case, because they don't give us a unit of measurement, we just say units squared. That's what we need to write. Good. I'm glad. But remember, it's not meters in this case. It's just units squared. But well done. Good. All right. Or you can just punch this into your calculator, guys, and it'll give you the right answer. Okay, let's move on. Let's do something a little bit more tricky. We'll skip that for now. Let's do question 4. I want you guys to just have a look at question 4. Give me a thumbs up. Do we know how to solve for this? Lutendo says yes. I'm glad, Lutendo, because we did a question very similar to this one on Monday. We did 2 of them that were very similar to this one on Monday. So I want to give you guys a few minutes to work out just 4.1.1 for me, number 1. Let's see if you can pop your answer in the chat. Okay, and I know sometimes we finish writing an exam and we just wipe everything, and guys, that's not a good thing to do. You can do it for every other subject, it's fine, but not for maths. Okay. Oh, Theo, good luck. But that's my favorite paper, I'll tell you. I don't like physics, I like chemistry. I've always liked chemistry more than physics. All right, 3 minutes. 3 minutes, guys, 3 minutes. Okay, let's do the things. All right, peeps, are we ready? Shall we chat? Let's have a look. Okay, let's remember again what ma'am said. Hey? Yes, Abu, but remember, we're not supposed to find the angle. Okay, that's not the point here, because the instruction literally says without using a calculator, which means we're not supposed to find the angle. I understand that it's a special angle and you can find it, but I'm telling you now, you've got the wrong answer. Let me show you why. I'll show you why. We don't have sine. We have cosec instead. Okay, so we couldn't possibly find the angle from this particular answer. Do you see what I mean? Okay, the angle will not come from cosec. It would have needed to come from sine. Okay, first thing I'm going to do is I'm going to draw a Cartesian plane. Okay, preferably in pencil so that we can figure out exactly what we're doing here. Then I'm going to go and configure this to make sure that cosec and theta are on their own. So I'm going to first transpose 2 over to the other side. So I'm going to end up with root 3 cosec theta equals -2. Okay, and then I want cosec theta on its own, divide by root 3, divide by root 3. Cancel, cancel. So cosec theta is equal to -2 over the square root of 3. Okay, that's the answer that we get. Now, we know cosec is actually the opposite of sine, right? It's the cousin of sine, the reciprocal. So sine theta will then need to be the opposite of the ratio that we've gotten. So that tells me then that sine of theta is the square root of 3 over, I should technically say -2, but we know that because this is r is the radius, it can never be negative, which means that negative over there needs to move up to the -√3. Thumbs up. Does that make sense, what ma'am has just done? Are we all okay with that? Yes? Okay, cool. All right, so now, now the instruction says that my theta should be in between 90 and 270. Again, I need to ask myself, quadrant 1, quadrant 2, 3, quadrant 4. Okay, now if it's between 90 and 270, it means it's somewhere over here. It's either going to be in here or in here. One of those two. Okay, one of those two. But if we read the instruction properly, we can see here that we know that sine is negative or y over r. Okay, sine is y over r, which means that our y value must be in the negative. Which quadrant is that? Quadrants 2 or 3? Where is our y negative? Good, it's in quadrant 3, which means we can't draw this up here. We need to draw our triangle that we're using over there. Okay, then I know that this part over here is the -√3, and my radius r over here is 2. Are we able to find x? Can we find the x value? Yes, thumbs up. Yes, I'll give you guys 2 minutes. Or actually, I'll give you 1 minute because you're going to just punch it into your calculator. We all know at this point we need to use Pythag. The answer should actually jump out at us. It is not 7, my darling. Have a look again. It's not 7. It's actually quite an easy answer. Okay, remember, you've got the longer side. So we're not adding, we're subtracting. Okay, you've got the hypotenuse, so we're subtracting, Narisha. And I want to see who's going to get the sign for our x value correct. That's it. Well done, Narisha. Beautiful work. That's the correct answer. Okay, I'm going to give you 10 more seconds, and then we're going to get into this question. Okay, that's your 10 seconds up. Okay, let's have a look at this quickly. I know that my x value, or x on that side, is going to equal to the square root of 2 squared minus the square root of -3 all squared. Okay, I can punch that into my calculator exactly the way that I'm looking at it. I do know that I'm going to get 4 over here minus the square root of 3 squared is just going to be 3, just the number 3, and the negative, because it's a squared, will become a positive. So this becomes 4 minus 3. Therefore, x must equal the root of 1, which is just 1. However, just like Narisha has pointed out, because our x is sitting on this side, it's sitting on the left-hand side, it's a negative x value. So it's not actually 1. The x value is -1. Well done, Narisha. Excellent work. All right. Okay, again, just for good measure so that they don't mark you down, add Pythag. Okay, add Pythag, just so they don't mark us down. All right, and then it makes answering question 1 so easy, and it also makes answering question 2 easy. I'm going to leave that to you guys. Yes, I'll give you 2 minutes because you're done with cos theta in seconds. You should be done with cos theta in just seconds. Are we ready? We've got about 20 seconds left. We're almost there. Okay. All right. Okay, let's have a look at these questions here. All right, we all know x is equal to 1. Okay, cos of theta becomes easy. Cos of theta is x over r. So that's going to be -1 over 2. That's our answer that we get here. This over here, we're going to have to do a little bit more work. So they want sine of theta. We know sine of theta is -3 over 2 multiplied by tan, which is y over x. So -√3 over -1. All of this over -1 over 2. Okay, so now we need to multiply where we can. Actually, it becomes quite simple once we do that. So over here, a negative and a negative will give us a positive answer. And then we can see here, √3 times √3 will just give us 3. So you'll end up with 3 over, at the bottom, I'll get -2 over -1 over 2. Now, again, I'm going to confess, guys, me and fractions that look like this, we are not friends. Even my grade 8s, they're like, ma'am, multiply top with top, multiply. I can't do it. My brain refuses. It cannot compute. I need to split it up. So I'm going to do this. -2 over 3 divided by -1 over 2. And then I'm going to tip and times so that I can actually see what I need to do. Otherwise, I'm just not going to be able to do it. Times -2 over 1. Okay, my brain just cannot compute, so I do it this way. Okay, that's going to be a positive answer, 6. Negative and negative positive, 3 times 2 is 6, divided by 2 times 1, 2, and that is equal to 3. The answer we're looking for is equal to 3. All right, so that's those 2 answers. Is everybody okay with this kind of trigonometry? Yes, lovely. No, you're right, Abu. Like when you really get the maths and it starts flowing, you really fall in love with it. Okay, I want us to have a look at a particular type of question. It is a special angles question. So Abu, you're welcome. You're very welcome. I just want us to note that this particular question is a 6-mark question. Okay. And I understand that they do say without using a calculator, which means that there's going to be quite a lot happening here in order for us to garner that 6 marks, which means we can't skip a single step. Okay, we cannot skip a single step in our process. We need to be very, very thorough with absolutely everything that we do in this question. I'm just going to check. Thumbs up if you are comfortable doing this question on your own. Thumbs down if you'd like me to to walk you through. I'm not going to walk you all the way there. I'm going to, like, you know, like when you're learning how to ride a bike, I'm going to pull along with you, and then I'm going to let you go. Okay. All right, Narisha, I'll walk with you. Step number one, you need to know your special angles. That is the most important thing here. Okay. If you don't know your special angles, you cannot complete this question effectively. Well, technically, you could put it into a calculator, but that would defeat the purpose of the 6 marks. Okay, so first thing we know, we've got two triangles, circles. We've got two triangles, and I almost said circles again. Woo, guys. Okay, we've got two triangles, the 60-30 triangle and the 45-degree triangle. So I'm going to do the 60, 30. This is a 90-degree angle, obviously. And this over here is 45 degrees. 45 degrees, we know that those two sides are equal to each other. This is actually an isosceles triangle. Okay, and then when we add the numbers, we just go 1, 2, √3. And for our 45, we go 1, 1, √2. Okay, step number one. We need to know these. Okay, if we don't know them, you could actually pick up your calculator. You could do this. You could draw the triangle, and you could pick up your calculator and go sine 60 equals, and your calculator will go √3/2. And then you can go in and put the √3 in, and you can put the 2 into the triangle. You can't just go with this answer. You need to actually draw the triangles, because it gets a little bit complicated. And if you try and just put the answer into the calculator altogether, it's not going to work. Okay, so you can do that. That would really help. But then you need to know each of these. Okay, now we can get into the question. Narisha, do you know what to do from here? Do I need to continue from here, or are you okay? We can go for it. I hope. I know. Okay. Everyone else, I know Abu's already finished with the answer. Everybody needs to catch up. Okay. Everybody needs to catch up. I'm going to give you guys a couple minutes to go through it. Okay. You'll be fine, Narisha. You got this. Just give another hint, just for vibes. I'll give you guys 2 more minutes. Yeah, or 3. I'll give you guys 3 more minutes. Sure. Tell us how it goes. Tell us how it goes, Abu. Yeah, if you don't have to. No, you'll be fine, Abu. I know it. I know you will. Are you done, Lutendo? Is that I got this? Yes? Good. Okay, the squared, we'll talk about the squared. Okay, Abu, we'll continue that conversation in just a little bit. Let's get into this question. Okay, like ma'am said, it's a 6-mark question, so you can't just give an answer. So Lutendo says, is there a way of remembering the cosec, cot, and sec? Yes, I'll show that to you in just a bit. I'm just quickly going to answer the question here. Okay, and then once I'm done with that, I'll show you what to do. Okay, so there's, okay. Sorry, the chat is distracting me a little. Okay, so we're going to start by making sure that we know each of these. We know cosec is sine, so, or the cousin of sine rather. So where sine is opposite over hypotenuse, cosec will be hypotenuse over opposite of 60. So there's our reference angle. So hypotenuse is 2 over opposite, which is the square root of 3. All of that squared. That's what that cosec squared part means. Plus, tan of 45 is quite easy actually, because tan is opposite over adjacent. So that's 1 over 1, which is just going to be 1 squared. Plus, sec of 60, sec is just the cousin of cos. So cos is 1 over 2 plus 1 over 2. Okay, and then we're just going to take away the brackets, and then because they are fractions, we're going to multiply. I'm sorry, we're going to find an LCD. Multiply to find an LCD. All right, so over here, I'm going to distribute. This is actually to the power of 1, so that we remember that. 2 squared will give us 4 over the square root of 3 squared will just give us 3 plus 1 plus a half. That's what we've got so far. I know that my LCD will have to be 6. Okay, so I'm going to put everything over 6. I'm going to multiply by 2 there. So I'm going to get 8 over 6 plus over here, I'm going to multiply by 1 plus 6. I'm sorry, multiply by 6. So plus 6 over 6 to get 1. Plus over here, I'm going to multiply by 3. So I'm going to get 3 over 6. And my final answer, 8 plus 6 is 14. Plus 3 is 17 over 6. I'm not correct. Oh, yes, Abu. I'm so sorry. Yes, you're absolutely correct. Haibo, you must speak up a lot quicker, guys. Look at me, guys. I'm lying to you. Sec 60 is not a half. That is cos of 60. Sec of 60 is 2 over 1. So this is technically 2 over 1. Thank you, Abu, which means my LCD is wrong. How lovely. My LCD is completely wrong. My LCD is actually 3. Sorry. Yes, it was a test and you passed. Well done. You passed. Thank you. Okay. So over here, I will still get 4 over 3 plus 3 over 3 plus times by 3, so 6 over 3. And then we'll just add the top. And our final answer is 13 over 3. I know, Narisha, I'm sorry. Okay. But well done, Abu. The correct answer is indeed 13 over 3. But I want us to look more at the fact that this is a whole process. And if you don't do all of these steps, you don't get the 6 marks. Okay, so you need to go through each of these. Okay, Lieutenant, I'm just going to address your answer, your question really quickly. Okay, so normally what I do is I go sine, cos, and tan. Now, with the reciprocals, I know that there's only one of them that has a t, and that's cot. Therefore, cot must go with tan. Okay, both of them have a t, therefore tan cot together. Okay, the next one is sec. I put sec with cos because if you look at it really carefully, sec looks like cos backwards. Yes? Cos, sec, they kind of look like backwards of each other. Yeah. And then obviously the only one that's left is cosec, and that will go with sine. Okay, so that's how I remember them. It helps to remember it that way. I don't know if anybody else has any other trick on how to remember, but for me, this is how. Okay, this is how I kind of remember that. Okay, all right, shall we get into a proof? Let's get into a proof really quickly. Okay, can I give you guys 5 minutes? Thumbs up if you know what to do. Thumbs down. Okay, I'm going to remind you guys again. Quadrilaterals are made up of what shape? What shape are they made up of? You know this, Narisha. You know this. Yes, you do. Good, Theo. Thank you, Theo, for helping Narisha out. Quadrilaterals are made of triangles. And if we know anything about our triangles, There's only one thing we can prove to make sure that everything is exactly the same. Well, there are two things, but the one is more accurate. What are we going to use to prove that this is a quadrilateral or that the triangles are exactly the same? It will have to be congruence. Okay, so we need to prove congruence. Yes, thumbs up. Are we able to do this question on our own? Thumbs down if you would like me to help. Okay, I'm happy to help. Okay, but as always, guys, as always, we need to read the information. Start by reading the information. It makes it so much simpler. Okay, it says here, in quadrilateral ABCD, AD is parallel to BC. We should already be thinking something. We should be thinking fun. Right? Soon as we see that two things are parallel, we should be thinking fun angles, either corresponding, co-interior, or alternate angles. Step number one. Then they tell us that angle B is equal to angle D. That's already very helpful because that thing and that thing are then equal to each other. Okay, now it says prove that ABCD is a parallelogram. Okay, now let's talk about the properties of a parallelogram. Go ahead. Anybody who remembers properties of a POM? There are a few. Opposite sides are equal. Good. Upsides equal. Opposite angles equal as well. Right? Opposite angles are also equal. Anything else? There are quite a few things. Opposite sides, opposite angles. Diagonals must bisect. Good. Diagonals bisect. Okay, I think these three is all we know. Okay, so now if we want to prove that ABCD is a parallelogram, we need two of these properties. Okay, we need two of them. If we look at what we've got at the moment, it's not going to be possible for us to use diagonals bisect. There are no diagonals, right? There's only one line. Okay, so I'm going to then need to use these two triangles that I've been given to prove these two properties. Okay, I'm going to ask again, thumbs up. Are we able to take it from here? Yes? Okay, I will remind you guys, we need to start with an RTP. That stands for required to prove. We are required, that's not how we spell required, required to prove. Now, at the RTP, you must then write these two things. We are required to prove that the opposite sides are equal, up sides equal, and up angles equal. Okay. So we need to do that because they don't give that to us. We need to show them exactly what it is that we're going to prove. Then from there we go proof, as we always. Okay, proof. In triangle something, 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 and triangle something. Okay, I'm going to stop there. Okay, that's all I'm saying. I'll leave you guys to finish up. And if there's anybody who'd like to unmute after this and give us the answer, that would be so great. Awesome, Abu. Let's give everyone else a couple more seconds. Can I give you 10 more seconds? Are we ready? Done. Okay, cool. All right, let's get started. Okay, so remember again, the most important part of this, map out your triangles properly. That's really going to help. Okay, so I'm going to say proof in triangle. Now I'm going to start at A, go down the short side, go past the long side. So in triangle ABC and triangle, now I need to start at C because I went there past the short side. So if I started, it will be short side down the middle. So I need to go up and that way. And in triangle CDA. Okay, I need 3 reasons in order to say that I've proven congruence, right? Therefore, okay, I'm going to start with the obvious. Actually, I'm going to put it over here. AC is common. Did we all manage to find that one? Yes, AC is common. Yeah, good. That was the nice one. Yes. Okay, we've also been told that angle B is equal to angle D. We can say that that's given information. Given, and then they've given us parallel lines, so we can use that. Let's use the parallel lines. I'm going to find out here that A2 is equal to C1 because of alternate angles. And I used AD parallel to BC. That's what I've used. Okay, 3 reasons in the back. Therefore, triangle ABC is congruent to triangle CDA. CDA, what's my reason? Let's see if we can find the reason properly. Has anybody figured out the reason? I only have one side, so I know exactly what that will have to be. There'll have to be a side somewhere. Good. It can't be angle side angle. You're quite right. Theo is correct. Okay, remember, Abu, if it was angle side angle, I would have to have that and that and that. I don't have those things. What I do have is I have angle B and I have angle A and I have a side. So this then would have to be angle, side. Okay. Okay, it takes a bit of practice. Okay, so this is lovely because now that we've made that assumption, or that now that we've proven that these 2 things are congruent, then that means the corresponding things in them are also equal, right? So that tells me then that AB is equal to CD, right? So I can say, therefore, AB is equal to CD. My reason is because they're congruent, but I just proved it, so let's not put that in there. Okay, I also know that BC will equal DA, right? Also, BC is equal to DA. Okay. I'm sorry, Narisha, and we already know AC must equal CA. That's common. That's a common side. So those 2 will be equal to each other. Okay, but that's not the only thing. We'll also know that the corresponding angles are equal to each other. We already know that A2 is equal to A1. Oh, sorry, C1. A2 is equal to C1. We proved it above. A2 is equal to C1. If we use the parallel lines in the opposite direction, that way, we can see that A1 is equal to C2. A1 is equal to C2. And we've also been given that angle B is equal to angle D. All right, so we've proved the two things that we needed to prove. We've proven that our opposite sides are equal, and we've also proved that our opposite angles are equal. Therefore, we can say, therefore, A, B, C, D is a parallelogram. Okay, and I know it gets a little bit complicated, but if you can do at least this part right, you will get the marks. Okay, well, not all the marks, but they will give you marks for at least knowing that you have to prove and actually using congruence to prove that. Okay,